Hi all, welcome to your first pre-tutorial learning series. Every week I'll be spending about 3 minutes to introduce concepts that we will be covering that week in our tutorial. So let's get started. What if I told you you can now write standard representation for ions? You don't have to memorize anything new and you will learn how to write isotope notations for atoms as well as ions. Let's start with a quick recap from SPM. So atoms and molecules, what do we know? We know that subatomic particles are divided into three, which is proton, neutron and electron. As well as we also know what are isotopes. Isotopes are two or more atoms of the same element with same number of protons in the nucleus but different number of neutrons. Isotopes also have same chemical properties but different physical properties. So let's see what we had in our Form 4 textbook. As you can see over here, this was something that was given in your Form 4 textbook. Okay, we noted this earlier in Form 4 as standard representation of an atom, whereby X here represents the symbol of element, A represents nuclear number, and Z represents proton number. Since this is only limited to atom, we now use the term isotope notations for a wider application. So as you can see, it's actually the same thing. Okay, element symbol X, nuclear number A, proton number Z. So let's recap some definitions. So nuclear number is the total number of protons and neutrons in the nucleus of an atom, also known as mass number. Proton number pula is the total number of protons in the nucleus of an atom. This is known as atomic number. Okay, so let's apply it in a question. So if you have a question here whereby let PB consists of 4 isotopes with nuclear number 204, 206, 207 and 208 respectively, and PB has a proton number of 82. So how can we write the isotope notation for lead? All we have to do is remember that the proton number is written at the bottom and the nuclear number is written on top. And that's it. You have an isotope notation for lead and its isotopes. Next example. As we can see here, we have strontium with a charge of +2. So I'm going to write it over there, charge +2. What about number of protons? Number of protons is quite obvious because that's the bottom number. And what about number of neutrons? Number of neutrons will be the nuclear number minus the number of protons, which would give us 52. And the mass number, as I told you, it was the nuclear number, so it would be 90. And for number of electrons, since this is positively charged, we need to know that number of electrons will be lesser than the number of protons. So the charge is +2, therefore the number of electrons will be 36. Now let's look at another example over here. We have got a net charge given to be 0. So immediately we know that the number of electrons and number of protons will be the same. And what about number of neutrons? So number of neutrons will be the mass number, which is the nuclear number, minus the number of protons. And that will be 12. And what atom is this? Okay, I say atom because there is no charge here. So this atom is actually our sodium. So let's move on to the next. And this is also an atom. As you can see, there is no charges. And I'm going to write here net charge 0. So the proton number and electron number is going to be the same. And the mass number will be 15. And finally, we have an ion again. So this is a negatively charged ion. That means we must have more electrons compared to protons. So the electrons will be 36. What about the neutrons? Remember, it is the mass number, nuclear number, minus the number of protons, not the electrons, yeah? So the answer here will be 47. And what element is this? This will be bromine with a negative charge. And the nuclear number is 82, followed by the proton number, 35. Alright, and that's it. That's about 3 minutes. Hope you get the basics, and I'll see you in class. Thank you.